Okay, for what we have in item number 4, we have the integral of x times the cosine of 4 pi x squared dx. And here we are again able to utilize substitution, and we have for the angle, which is quadratic, where we have 4 pi x squared, we can use the derivative to cancel out x through substitution. So we can say that u is equal to 4 pi x squared, and taking the differential of both sides, okay, we have that du is equal to 8 pi x dx. And for what we have, rewriting dx in terms of du, okay, we have du over 8 pi x is equal to dx. And so for what we have in terms of substitution, okay, we're going to have the next portion, okay, we have x times the cosine, okay, we have u in place of 4 pi x squared, and again in place of dx momentarily we have du over 8 pi x. And with the cross multiplication, okay, we have the x's to go out, and so we have a numerical coefficient that will be brought, or that can be brought on the outside, at 1 over 8 pi. You have times the integral of the cosine of u du, and the antiderivative of cosine is going to be sine, and so we have 1 over 8 pi times the sine of u followed by the constant. And once again, putting back in for u, okay, we have the angle at 4 pi x squared, and so for that result, okay, we see we have 1 over 8 pi times the sine of 4 pi x squared followed by the constant, or sine of 4 pi x squared all over 8 pi plus the constant. Now, for what we have in the case problem number 5, okay, we have in this encounter we have a constant over sum of squares, and for what we have in this situation, okay, we have 1 over 4 plus 5x squared dx. Okay, so with the constant over sum of squares, okay, this is going to be a backdrop to what will be leading up to an arctangent term for the antiderivative. Okay, so we can rewrite these terms as sums of squares. Okay, and so we have 1 over 2 squared and 5x squared. Okay, now 5x squared is going to be the perfect square of the square root of 5 times x. And because of what we have quantified in x, okay, has a derivative other than 1, okay, you're looking at principles of substitution, and again we can set u for the x term that is quantified. So I have u is equal to the square root of 5 times x, and thus we have du is equal to the square root of 5 dx, and rewriting dx in terms of du, okay, we have the du over square root of 5 is equal to dx. And so in carrying over what we have for the substitution, okay, we have once again we have 1 over 2 squared, and then we have once again in place of square root of 5 times x we have u squared, and as for dx we have du over the square root of 5. Okay. And so in carrying out what we have at this stage, we have the numerical coefficient that we can factor out and put in front of the integrand. We say 1 over the square root of 5 times once again 1 all over 2 squared plus u squared du, and so we have in the lead up to the arctangent we have 1 over the square root of 5, okay, then we have times 1 over a is represented by 2, so we have times 1/2, and then we have times the arctangent of u over a, which in this case is going to be at u over 2 followed by the constant. And then we have, with the back substitution, okay, we end up with 1 over 2 times the square root of 5. And we have times the arctangent, okay, the square root of 5 times x all over 2 followed by the constant. And so that will be the result for what we get in number 5. Now, and what we have in reference to number 6, okay, now this one is going to lead up to an arc sine, looks like. And for what we have in this particular problem is that we have the square root of terms, okay, that will lead up to, once again, an arc sine. And for the terms that we have inside the radical, I'll give you the setup in this problem. So we have within the radical initially, and I will set the problem up in just a moment. But here we have 18x minus x squared, and if we set this up as sum of squares or as a difference of squares, okay, we have 18x minus x squared, and if we rearrange the terms, we have negative x squared plus 18x. And for what we have in this particular situation, okay, if we look at factoring out the negative x squared plus 18x, this will be the negative of x squared minus 18x. And in looking at completing the square, okay, so we have, again, with the coefficient negative 18, okay, we're going to take half of this and square. So half of negative 18, this is a negative 9 squared, which is going to be at 81. And so as we continue, what we have, okay, again, we have the negative of x squared minus 18x, okay, and we're going to add 81, okay, but at the same token, to keep it in balance, okay, relative to what it was to begin with. Now, as you add 81 within the parentheses, and considering the distribution of the minus sign, okay, adding 81 within the parentheses is actually subtracting 81 in the big picture. So to keep it all in sync, we are now looking at undoing the subtraction of 81 by adding 81, okay, just to keep it even. And now for the setup that we have, okay, for our trinomial, okay, we're looking at the negative of the quantity of x squared minus 18x plus 81, so that is going to be the negative of the quantity of x minus 9 squared, and 81 is the square of 9. And as we write this up, this time with the constant at the front, we have 9 squared minus the quantity of x minus 9 squared. And so for the integration problem that we have, okay, so we have 25 over the square root of 18x minus x squared dx. And so for what we have in this one, okay, now we have 18x minus x squared, and we have reduced this to 9 squared minus the quantity of x minus 9 squared. And working with this integral, so we have 25 times the integral of the reciprocal of the square root of 9 squared minus the quantity of x minus 9 squared dx. And the nice thing about this one, I know that the work is tedious, but at least x minus 9 has a derivative that goes to 1, so no special substitution is going to be needed. And so for what we have in this case, okay, we have for the antiderivative, we have 25, and then for the antiderivative of 1 over the square root of 9 squared minus the square of the quantity of x minus 9. Okay, this would be the arc sine of u over a, which in this case is going to be x minus 9 all over 9, followed by the constant, and that would be the final answer in this instance.